Good morning everyone. आप सभी को नमस्ते, नमस्कारा, आदाब, सत श्री अकाल, वनकम, केम छो, जय जिनेंद्र to everybody present here. It gives me immense pleasure as I welcome you all to the Asia's largest defense expo, Def Expo 2022. There's so many prominent leaders present here along with the participants as well. I would like to extend a hearty welcome to everybody with a big round of applause. Can we have a big round of applause? Today, we are gathered here to discuss on the futuristic technology for defense production. This session is by ASOHM. The world war, the global military equipment is witnessing significant transformations and it's leveraging technologies, trends to strengthen capabilities besides giving an advantageous position of lead start in that field. Today, conventional warfare is increasingly being replaced by hybrid approaches that also combine cyber warfare and other frontiers. To optimize defense operations and augment military efficiency, major trends include artificial intelligence, robotics, and the Internet of Things. India is taking rapid strides to establish its presence as a formidable force among the most powerful nations in the world. Fortifying its defense therefore becomes an ardent requirement necessary to satisfy many of its growth ambitions. As is well known that due to the importance of global security concerns, border disputes, and maritime affairs, countries around the world are today focusing on their military modernization and the demand for military equipment increasing rapidly. Today's session is thus persistent to taking this agenda forward. Now, it gives me immense pleasure as I would like to welcome all the esteemed members on the stage. As I may call upon, I'd like to request everybody please kindly put your phone on silent mode. As I would like to call upon Ms. Preeti Patel, MD, Aerospace Enterprises Private Limited. Ma'am, request you to please kindly join in. And I request everybody to please give a big round of applause as I call upon all the members on the stage. Moving on, I would like to call upon Commander Ajay Panwar, Indian Naval Veteran, Senior Manager, Aerospace and Defense, Ernst & Young, LLP. I would like to call upon Mr. Ashwini Bhargava, Senior Director, Boeing India. Dr. R. Shivaraman, Director, Big Bang Boom Solutions Private Limited. Mr. Kiran Dambla, Chief Operating Officer, Tata Lockheed Martin Aerostructures Limited. Mr. Ashish Saraf, Vice President and Country Director, India Thales Group. Mr. Pratish Gandhi, Director, India Strategic Development, General Atomics. Sir, please join us. Thank you. I would also like to welcome Air Vice Marshal P.S. Sareen, VSM Assistant Chief of the Air Staff Engineering A, Indian Air Force. Can we have Mr. Dhaval R, Chairman for Defense Cluster, ASHM, Gujarat Council. And finally, we will also be having the company of Shri Ajay Bhattji, Honorable Raksha Mantri, Minister of Defense, Government of India in some time. From Big Bang Boom Solutions, we will be having Praveen Dwarkanath sir, who will be joining us in some time. Without further ado, we would be starting this session. For the welcome address, I would like to welcome Ms. Preeti Patel. Ma'am, could you please join us?
Good morning, ladies and gentlemen. Kem cho? Majama cho? Okay. For our guests here, I hope you're enjoying the hospitality of Gujarat, the delicious food, and all the festivities that are happening in the Defense Expo. The drone show at Sabarmati was really outstanding. The topic of today's seminar, Futuristic Defense Technologies, is absolutely apt. We live in very interesting times, and the government efforts are phenomenal for the defense industry to keep progressing. I'm also a chair of the ASSOCHAM Women Committee, and there are few things that I would like to say from a woman's perspective, if I may. For all of us, we look at security very microscopically. So any invasion in our physical, emotional space is also a security threat. So when the topic is futuristic defense technology, it is so important actually for every individual to consider not only the land, air and water, but to consider all the space for defense and security, which would be in today's times data, space, cyberspace, biological, genomic, psychological, and the list is endless. So we believe that a nation's ability to fight a modern warfare is as good as its technical abilities. And in this perspective, there are several advancements that are happening all over the world. Some of them I would like to enumerate. For example, there is self-steering bullets. There's research happening on unmanned submarine hunter. There's advanced research happening in laser cannon space. There's a concept called seabird for the naval space. Besides, there are a whole lot of research that is happening in stealth technologies. So you have something called extra-thrill bombers, plasma protections. There is also in a biological space research happening in camouflage technologies, which is there are scientists working on a substance called reflectin, and that is derived from a squid, and that can be used for camouflage in several aspects. There is also research happening in electromagnetic field for instead of using gunpowder. And in space, there is also like a space satellite melter that we need to, get into our plethora of arms. So, futuristic defense technologies, the esteemed panel will run you through each and every one of them. I am just giving you a brief. The interesting thing that the government programs have is IDEX and TIE, and there is a lot of assistance as well as funding available even to private sector, and this is something that is notable and a moment to rejoice. India is one of the largest manpower for technical advancements. A lot of companies from the world look at India for manpower as well as for innovation. So we are poised actually to be in this space in a great way. The government has already provided infrastructure, is providing several policies, and there is enough skilled manpower. There is no way to stop India from being one of the forerunners in defense technologies. So having said all this, many changes that are taking place, but one thing always remains the same, and that is it's our task and our duty to ensure the security of our country against any aggressor. Jai Hind, I welcome you all. Let's have a fruitful session.
Ma'am, if you can hold on there, I will start the panel discussion straight away because I know you have to leave for
very much. No, no. I need to leave.
I have a question for you.
Yes.
It is so nice to see, you are into the space of manufacturing the armament.
Yes.
Can you tell us what is your next phase?
Keep the question on the mic so the video conference people will be clear also.
Good morning, ladies and gentlemen. I have started the panel discussion before because she has to go for another event. And please bear with me for this short jumping the gun, as they say. Ma'am, I have a question for you.
Yeah.
You are into manufacturing small arms, and it is nice to see companies getting into armaments. Can you tell us what would be your next stage, and will technologies like 3D printing and deep tech be enablers, and if so, how?
So, I'm a woman organization in defense manufacturing. We are a very tiny speck in this macrocosm of defense production, right? But we started small, and what we started was to increase the operational efficiency of the existing weapon systems. We also noticed that there are several old weapons which you are in service since 10 to 15 years, and we want to refurbish them and make them last even longer, because India is a country which is cost conscious, and we should all be. So we started step by step, and we have manufactured non-lethal segment rifles. We have a range which we have manufactured for crowd management, again a non-lethal space. In the lethal space, we have done a trial production, and that's gone into the approval, and we are doing pretty well. So step by step, we have chosen a segment which is small weapon systems, which we can actually do, and my teams are capable for the same. We are based out of Rajkot, which is a metallurgical hub. It has great potential and capabilities. We also have a cluster which is doing the optimization. So as a small organization, this is something which we can do, and we keep on researching on newer technologies, how to improve the technology in the space that we are in, right? So in the small arms systems, that's what we do. And of course, 3D printing and newer materials are what we look at, because if it's wood or metal, that's not going to last in the future. We have different operational requirements, we have different cost and such requirements, and we are very keen, and we already utilize 3D printing technologies.
Ma'am, are you also going to get into ammunition part in the future?
Currently, we are focused since the last 3 years only on weapons. Once we are, really mastered the thing, then yes, step by step we look at ammunition. Yes.
Thank you, ma'am. Well, ladies and gentlemen, she is Miss Preeti Patel. Request you to all give her a big hand, please.
Thank you. Sorry, there's one more thing. We are based out of Gujarat Pavilion 12A, and we would all invite you to please visit us and see what we are doing. Thank you.
Thank you so much, ma'am, for the insights. So moving on, we would like to have a video. I would like to talk about Sterlite Technologies. A multi-layered solution made on Atmanirbhar technology has an end-to-end capability to deliver 360-degree situational awareness and a seamless threat response mechanism. It leverages the power of hybrid sensing technologies combined with analytics and a state-of-art command and control center. The most critical component of this solution is fiber optic sensing. It is an innovative and flexible mechanism that centrally leverages optics technology to provide real-time monitoring of large parameter intrusions. It is capable of monitoring fluctuations in the optical signal due to the vibration of the sensor. To know more about this, I would like to ask to please kindly play the AV.
India needs digital frontiers with state-of-the-art intelligence and surveillance capabilities to maintain the territorial integrity and meet the challenges emanating from across the borders. Here's presenting Smart Digital Frontier Solution. This multi-tiered solution is based on Atmanirbhar Bharat technology and will use the next-gen digital technologies aimed at enabling our forces with better situational awareness, shortest response time and reduction in human casualties during counter-infiltration or terrorist operations. It will act as a force multiplier, an additional layer of security that would shrink the ODA loop during active hostilities. This comprehensive solution can strengthen our borders and strategic bases through the deployment of a variety of smart sensors, secure wireless networks, command and control centers. The three-layered solutions will comprise the following components. Layer 1, eyes and ears of the digital frontier, deploys a customized sensor network consisting of physical and virtual fencing. This includes electric fencing, fiber optic sensing, and surveillance cameras. On the virtual side, technologies like laser walls, unattended sensors, sonars and drones will be used. Layer 2, 4G private LTE or 5G based wireless and converged network. This secure layer would carry the data from the millions of sensors of Layer 1 to the command and control center. Redundancy would be engineered using satellite connectivity for all-weather, fail-safe, secure connectivity. Layer 3, Unified Command and Control Center. Data from the sensors would be collated, stored and published at the edge data centers. Advanced AI-enabled engines would facilitate the conversion of data into actionable information that would be communicated seamlessly to the local commanders as well as other decision makers. The smart digital frontier will be the eyes and ears guarding our nation, shouldering the responsibility with our valiant soldiers and helping our forces in delivering the decisive punch on our adversaries.
Wonderful video looking at how technology is changing and evolving, and it will help in a lot of ways for the defense sector. Moving on, I would like to invite Commander Ajay Panwar, Indian Naval veteran. Sir, if you could please start the session for the panel discussion.
Welcome back. Welcome back, and a very good morning, ladies and gentlemen. We start this session on futuristic technology in the defense production. Technology, right from the beginning, if you see, it has evolved and it is changing. If anyone who is stagnated in a particular technology, he is wiped out. We have seen n number of cases, n number of companies which were doing very good. They didn't adapt to the technology, and they are nowhere in the horizon today. Technology in the defense, particularly in the emerging technology or the futuristic technology, is a very closely guarded secret, and it is seldomly in the open domain, as it gives the first move advantages to any company or any defense. I feel futuristic technology should be adaptable and should have ease to migrate from the existing technologies. It should be cost effective so that it has an outreach in the market. Last but not the least, I personally would like the emerging futuristic technologies in the defense to adapt more towards being a deterrent enabler than being a source of destruction. Now, what are these futuristic technologies we are talking about? They are artificial intelligence. Recently, the Honorable Minister of Commerce had, in one of the event, mentioned that India in 2040s, it will be a world leader if we are able to adapt to the artificial intelligence in our technology in every sector, not only in defense. We have a very good panel of industry captains, and I'm sure you all are waiting to hear from them, their perspective on the futuristic technologies, what they are or their companies are now evolving. My first speaker I would call upon is Mr. Kiran Dambala from Tata Lockheed. Over to you, sir.
Thank you, Commander. Appreciate the opportunity. So, since we're here to speak about futuristic technology in defense production, I'm going to take a slightly different route here. I'm going to suggest that we actually take a trip down memory lane from my standpoint, from my perspective. So I work for Lockheed Martin, and back in the 2009 timeframe, we partnered with the Tata Aerospace and Defense to set up a joint venture, first of its kind back then, and transition the manufacturing of some aerostructure components here. And we started off with the C-130J empennage, which is the tail of the aircraft, a pretty major component. And the transition across the Atlantic was something that was difficult for people to believe in. So what I'd like to say is, right now, as a person who is heading the joint venture, it has been an unbelievable story, which I think will lead us to the discussion about how we can actually have a platform within India for future growth in defense production by just using this as a business case or a case study. So back in 2010, it was a greenfield project. Tata Aerospace and Defense set up all the infrastructure. Lockheed Martin subject matter experts came down, set up the tooling, and the workforce that was recruited by Tata Aerospace and Defense was trained and developed over time. And that led actually to the first empennage being delivered back to Lockheed Martin for the C-130J aircraft, the cargo plane, which actually Indian Air Force has 12 of them right now. So given that this is a legacy aircraft, everything was on paper, what happened is the joint venture here took the stance of actually digitization, but digitization was not that simple because interpretation of what was on paper was quite difficult. So that led to actually reverse engineering. And this is where we can actually leverage the talent within India that can actually take on such complex problems, apply their skills, reverse engineer, digitize, and then we leverage some of the offset funding from Lockheed Martin to actually develop our suppliers with some machining capability, special process capability. And that led to actually, over time, indigenizing about 87% of the parts. And this is a complex aerostructure with more than 2,500 parts, and now you're looking at 87% of it India content by volume, parts-wise. So we didn't stop there. We've continued on. We've delivered more than 185 empennages back to Lockheed Martin in the US. The second round of indigenization, we have actually, again, leveraged some offset funding. We've actually developed one of its kind metal-to-metal bonding facility, which reduces the raw material usage and increases the structural integrity, reduces the cycle time, and then helps reduce the cost for the customer. Now, in the second round, we also went into furthermore capabilities by leveraging some offset funding and helped our suppliers develop long bed machining, 6 meters, 8 meters type parts. That's not usually done in India by our supply chain. Well, then we also went into stretch forming for these complex contours. Again, what we're doing along the way is actually developing a ecosystem, a workforce that is essentially self-reliant. All about Atmanirbhar Bharat, but we started about 12 years ago on this journey, so when it wasn't even something that was a big concept at the time. So my point here is we've always constantly looked at being future ready, ahead and ready, and that involves partnering with OEMs like Lockheed Martin and, of course, transfer of technology, using the subject matter experts, synergizing with the Indian workforce here that is super talented, in my opinion. 2.5 years that I've been here, first job outside of Texas, I've never seen a workforce this talented and this young, actually. So, point I'm trying to make is, all this actually led Lockheed Martin to have so much confidence in our joint venture that then they asked us to go ahead and industrialize the fighter wing. Now, the fighter wing that we have is another complex product. It's a wet wing, 12,000 hours of flying hours, life, 9 Gs that it has to be capable of. Again, the workforce stepped up with digitization via reverse engineering, but this time we didn't wait to indigenize. We started with the first article by indigenizing a little more than 70%, by again developing an ecosystem around us with suppliers, by holding their hands, sometimes bringing Lockheed Martin engineers and our joint venture engineers to support the suppliers and not pushing them to just work on their own. So this developing of suppliers concept, developing of new capabilities, such as thin wall tubes that actually go into the wing, that has not been done before, where there was a high failure rate that we were able to actually accomplish successfully, is really the future of defense production in India. The synergy between larger aerospace and defense companies in India, the OEMs abroad, and the smaller MSMEs within India. And then we've actually taken it further with ERP systems, like migrating over to SAP HANA, doing total productive maintenance so that we can reduce the breakdown rate and reduce the cycle time, which allowed us to actually ship 32 shipsets last year, unprecedented even during COVID times, which it was something that was a testament to this whole framework that we have built. Now, going forward, we spoke about artificial intelligence. My point is, before we get into artificial intelligence, we should get into some autonomous systems here, and that starts by data analytics. So you automate a lot of your data, then you go into data analytics, and then you actually have these sensors that actually make your systems autonomous. And then you go into artificial intelligence that allows you to basically be an enabler for not just your facility, but your suppliers as well, that you have direct contact with, and you kind of remove the human in the loop if you can. So that's as far as my take is on futuristic technology for defense production, but it starts with the right kind of people, which I think our aerospace and defense really has done an amazing job of recruiting people through NGOs, from some rural areas, having a state-of-the-art training center.
So I have a question for you. You are into Tata and Lockheed. You have formed a JV, and you are into aerostructure. In your opinion, what are the issues in the aerostructure, whether it is the material or the technologies, which Indian companies are unable to?
Yeah, thank you for that question. I actually meant to cover that, so I'm glad he kind of put me on the spot there. But I would say one thing. At the end of the day, I keep speaking about indigenization. Why is it important? Well, of course, it's important for self-reliance, but it also makes it affordable for the end customer. So if we want to make our product affordable for our end customer, we have to indigenize 100%. What does that mean? Raw material. So let's talk about raw material. Obviously, we don't have enough raw material. We still have to go source from US, UK, mainly those countries. The issue I see is sometimes the raw material market is not that big within India, so there's not enough incentive. Why can't we go global? And Commander Ajay and I have spoken about it. Why can't we go global with our suppliers? Some level of government support, some level of industry support coming together, developing raw material suppliers, certainly will be a game changer for us to be 100% self-reliant. That's my main issue. There are others, but this is the main issue that I would actually refer to.
Thank you, sir. My next speaker is Mr. Pritish Gandhi, Director, India Strategic Development, General Atomics. General Atomic has made its impact in the area of drones. Which are the areas that you would want to collaborate with Indian industry? Would it be in space or in battery technologies or any other technologies? What you think the Indian companies are ready and are adaptable to these new emerging technologies?
This meeting is being recorded.
Thank you, sir. Thank you for that question. And right, thank you all for being here, and thanks to ASSOCHAM for giving us this opportunity. So, with regard to the question by Commander Panwar, basically General Atomics is, as you know, is a world leader in this field of unmanned aerial vehicles. Now, I would like to differentiate between the term drones and the term remotely piloted aircraft system, which is now the commercially accepted term. Drones is very usually used, but it generally conveys a large and diversified area of autonomous vehicles. So, RPAs, or UAVs as they are called, are definitely the driving force behind unmanned aircraft revolution around in the world presently. And General Atomics has been right at the forefront of this revolution in technology, right from the early incubating years of 1975. And since then, today, there are over about 10 or 11 high altitude, medium altitude, long range, short range endurance air combat vehicles which have been manufactured, and they have served over 7.5 million hours in various capacities with various armed forces around the world. So, with regard to India, obviously there is a lot of potential in the Indian industry, and General Atomics has realized the need to collaborate with the Indian industry in that regard. We have already set up a lot of collaborations in the aeronautical field for sensor exploitation development, for development of AI analysis systems and imagery analysis systems, for exploitation of the data which comes off these RPAs. And in that regard, our partnerships with Third Eye Tech, 114 AI, and Ramco Systems, which is essentially based in Chennai, but the firm's US division has already been announced. Also, the best part about General Atomics unmanned aerial vehicle systems is that it follows a global approach for the fleet-wide sustenance. There is a lot of emphasis and focus on making sure that the global supply chain partners are not only restricted to CONUS, but they are also able to support global operations wherever the aircraft and the ground systems are deployed. Apart from that, in India, General Atomics is, as you know, is a fairly diversified country with almost 27 verticals, forays into nuclear research and energy in the field of electromagnetics, also satellite technology recently with the launch of its modular satellite 2 weeks ago. So in India, we are collaborating with Bharat Forge, and in the field of lithium-ion batteries, General Atomics manufactures lithium-ion fault-tolerant batteries, which are very, very beneficial for critical applications such as submarines, underwater vehicles and sensors, as well as surface vessels. So there are a lot of collaborative areas that General Atomics is working with, apart from Bharat Forge, also in this regard. And I'm happy to answer questions, if any, on this. Thank you.
Commander Ajay Panwar will be joining us in exactly 5 minutes from now. He has another session where he had to be attended. But moving on to the next speaker, I would like to ask Mr. Ashwini Bhargava, sir, if you could please put in some key points towards this from Boeing India.
All right, thank you for this opportunity. So as introduction, I lead the supply chain team for Boeing in India. We already source about 8,000 crores worth of products and services every year from India. And we have a fleet of about 300 suppliers. 25%, which is about 75 of them, are MSMEs. So we have a very elaborate ecosystem. And just for you to be aware what we are sourcing, we buy structures, we buy forgings, we buy electrical parts, harnesses, panels. Now getting into thermoplastics, we have a broader width of what we source from India. And we're not going to stop here. And I'll also tell you, in the last 18 months, we have signed contracts in India which are over 10,000 crores with Indian suppliers. So that just tells you that our intent is to grow here in country. And we have suppliers who are performing at the global stage. We just came back from a very elaborate ceremony of supplier awards that took place in Los Angeles, and we had a supplier from India out of the 9 suppliers that was recognized as the supplier of the year. And we are doing it consistently well year over year. So if you have that level of scale of sourcing in country, if you have suppliers who are winning at the global level, then there has to be an element of futuristic technology, which is what the topic of discussion is all about. And I can tell you from my experience, a lot of people say futuristic technology. I believe we are there already halfway through. And I'll elaborate what it means. So before we go to that point, I think if you are to go and do more, we have said this publicly that we'd like to do more in country. But if you have to do more, you have to go to more complex parts, the bigger parts, and the parts that could potentially require a different level of technological intervention. The parts which typically people think could be done in US or Europe, in Japan, and so forth. I think we have potential in India to scale up and do much more than what is happening today. Now, in that context, it is very important for us to stay current with the technology that is known to us and that is going to happen in the future. And we are marching in that direction. So I think that's a very important element from our perspective. Now, for us to go to that level, we have to understand what are we shooting for. I firmly believe, all the discussions that you hear in different forums in defense manufacturing is centered around what we can do for the platforms in country. But I'm a firm believer, if you're able to export, if you're able to sell to US or to customers outside of India, you can handle what India wants very easily. In that context, 99.5% plus of what we do from India is all exports. So what does the customer look for? If you're to compete globally, if you have to grow your supply chain business, what does the customer look for? One is the cost. We all know that. The second is quality. I think quality will be number one. Then delivery, and then also the rates. More than the defense part of it, in the aerospace world, you've got to scale up majorly to be in the world stage. So for you to achieve, or for us to achieve this, it is not just a question of do the part in India and you'll get all of this. For example, in the delivery world, if we are to talk about supply chain deliveries, we use a new term called supply chain resilience. So the question is, can you supply a higher rate of output even in disruptions like pandemic, which is what we have done successfully over the last 2 years. And we are perhaps the only region, or one of the very few regions in the world, operating at a very high level of on-time delivery and quality out of India. So the definition of delivery is different. Similarly, if you talk about cost, why do people come to India? The first response will be, oh, the cost of labor is cheap, or is lower. And that definition has to change, and that is changing over a period of time. We are not just about low-cost labor. It's also about the value and the innovation that we bring to the table. And in context of innovation and the value, you cannot separate the technology with what the offering is from India. Quality. We all know the culture. I've been talking in different forums, and I asked this question, and I'll put this question to this group also. How many people in this room can say that they deliver 100% quality again and again and again? Wherever I've spoken in the past, there are very few takers or very few people who raise their hand. That is because you cannot solve all the problem by human intervention. There has to be a technology piece that helps you and enable you to secure the high level of quality. Inspections, that's the other one. Sorry, is there any question? Okay, so then you talk about inspections, so in the world of inspection, again, you cannot do everything with human intervention. So you have to have technology that helps you do that. So in Boeing, we have gone ahead and implemented several things, and I'll speak of a few examples. There are different elements of future technology. One is the product technology. Kiran talked about structures that we have. Boeing has moved to something called FSTA, the full-scale determinant assembly. And that, in my opinion, is the future of structures across the globe. And I'm happy to say that the most complex of those parts are getting done in India. So the suppliers are already making FSTA parts, which requires very few tools, which are a big pain from the structures perspective. And then in the electronics world, we're using smart technology. Many more examples on the product side. Digitization is already covered, so I won't talk about digitalization more importantly. Now, if you go to the manufacturing world, we have implemented robotics in India. We have implemented flexible manufacturing system. There's virtual reality, there's IoT, you name a few, we are into all of it. So if you look at the machining world, a lot of people will think that, hey, if you implement automation, you'll increase the cost. But that is not the case. You have to decide where the technology has to be used. And I think one of the important elements is you have to use the technology wisely. The solution to everything is not futuristic technology. You have to identify where the technology will make more sense. So we have implemented robotics to reduce the setup time when it comes to machining. We have used flexible manufacturing system where there are 5 machines operated by one individual for high-rate parts. We have used virtual reality to train people. Painting, for example, is, people think it's an easy thing, but when you actually go on the job, you have to be very meticulous in doing that kind of painting on the job. So that is being handled by virtual reality. And then, of course, IoT, everybody's familiar with this, more in the services world. I think it's playing a significant role there. And I'll give you an example in the quality or inspection world. How many people in this room know that you cannot afford to have a foreign object inside the aerospace part? So even a piece of hair inside the parts you deliver could find its way in the fuel tank, and you never know what happens with that. So you have to deliver a part without any single foreign object. Now we are making Apache fuselage in our joint venture in Hyderabad. That, you can imagine, Apache fuselage body is like huge. So is it possible for a human being to go at every corner and find out if there's a foreign object? And that is where the new technology comes into picture, which is more like artificial intelligence and more maybe of machine learning. So we have implemented artificial intelligence and machine learning in our supply chain world. Therefore, I would say, and I know there are other speakers too, and I'll be happy to take questions, but in context of the futuristic technologies, I think we understand what it is. I think we understand, and one of the things at the India level we have to tweak is to understand it'll require investment, so people will be a little reluctant to invest that much. But as long as you know you have to invest in the right areas, you'll never be short of ideas, you'll never be short of the benefits that it can provide. So we are getting there. I will say we are almost halfway there. And we're pretty excited to be a part of this journey. And I agree with some of the other panelists that we could be ahead of others in this game, in the journey. So because India is capable of doing innovation. We have jumped from the rank of 81 to about 40 in the GII index, which talks about how innovation is moving in India. It's a question of a little bit of more understanding where to use the technology and then run with it. That's it. Thanks.
Thank you, Mr. Ashwani. So I would like to request you if there's any question from...
Yeah, in fact, I've got a question for you and maybe a colleague panelist, fellow panelist from General Atomics also. Can you elucidate, you both mentioned that you're creating an ecosystem which will take manufacturing and more so futuristic manufacturing forward in India. As a user from the Indian Air Force, which is a major defense customer in aviation, what we are looking at is how are these spin-offs going to accrue to the industry? Just as the Maruti 800 brought about a revolution in automobiles, manufacturing in India, and today we have every major manufacturer available here. How are you facilitating, ushering in of the support for maybe the existing platforms operated in this country, maybe not exclusive to defense, but other MROs in the civil sector? Are you in the process of setting up any training establishments to sustain that ecosystem, to build on that ecosystem? Maybe you would like to elucidate on those aspects.
All right, I'll go in first. Okay. So, 3 or 4 things, and I can go on and talk on this subject. So one, the topic of this discussion is future technology in manufacturing. I believe the technology is best used if it is integrated from design to manufacturing. So to answer your question, how will the customer like Indian Air Force benefit from that? I think you get a better product because the technology is not just about manufacturing, but also, showing from product to the end product which is manufactured. In fact, some of the production systems are designed around the design of an aircraft. And you'll see more and more with different OEMs across the globe. Now, as far as skill development is concerned, you're absolutely right. I mean, if we do not have a good definition of experts here, then we'll probably struggle. Now, I'll say one thing, what we are doing with the industry and one thing that I'm doing with my team. We have extended the definition of supply chain in India for Boeing, which means, a lot of people will think that supply chain is about sourcing parts and sending abroad. But we have developed a fleet of subject matter experts in India who are helping the globe. And that includes the technology, and we are helping the suppliers also. So we are one of the very few OEMs around the globe who will put the resources to develop the industry players when we put up a new job at them. Okay? We also run skill development programs with the industry. So we've done about 12 programs so far, training more than 400 kids, I'll say, because they come out of, they're from humble background, they need some training to be job ready. So we have done it with in fact, 2 days back, we announced a program with Jabil, which is a supplier for us in Ahmedabad. We have done it with 12 suppliers. We do 8 weeks of classroom training and about 8 months of industry training. We're not stopping here because we know that if we have to grow here, we have to train the manpower. And this also includes people with disabilities. So some of the fleet that we are training have people who have either hearing disability or speech disability, but are the best performers on the aerospace products. So a lot of work is going on in the skill development. So you're right. I mean, it has to complement what we're talking about.
Right, so I'll thank you for that question, sir. And I feel that question is extremely relevant, especially with the drive in the country for Atmanirbharta or self-reliance. And also to bring to fore what Kiran had also spoken earlier about setting up the joint venture for the manufacture of the Apache fuselages and the Chinook fuselages here in country. Now, sir, I think the very simple moot fact is that no country can go it alone in global or even localized production. Even a large firm like Boeing or Lockheed and small firms like General Atomics, 100% of the product is never made in their factories. It is all built on collaboration. And what essentially is collaboration? It is essentially setting up a design and development parameter for the local industry to come in and support a particular end product, which is going to be used by the end customer. Now, the end customer, especially the Indian Armed Forces, have extremely focused and extremely, I would say, role-specific requirements. Now, these role-specific requirements are based on their assessments of threat, on assessments of deployment, or assessments of capability that they need, not only present and in the future. So, for a foreign OEM to essentially come into the country and just sell something which is not, and the term which I like to use, and I've used before also, is tropicalization. Essentially, you are making a platform in a foreign country, and when you come back and use it here in India, it is not modified or sort of retrofitted to the environmental conditions, to the operating conditions, to the maintenance conditions here in India. And that obviously is something which cannot happen without the support of the local industry. It simply cannot survive the test of time. So it is not only essential for foreign OEMs to come and do a significant value add to not only the global supply chain, the technology contribution, as well as ensuring that life cycle sustainability is achieved through local resources. So in that regard, General Atomics has already been doing this globally in its recent programs. For example, the MQ-9B platform, which is basically the Guardian platform, the latest version of the Predator B UAV, a large-scale UAV. Now, let me tell you a little about this UAV. This UAV is roughly about 7.1 tons in weight. The wingspan is about 80 feet. It can fly up to 50,000 feet and remain airborne for 40 hours. And it is not only combat worthy, it is armed. It can carry a whole host of sensors and payloads which are carried by most modern ISR aircraft, basically intelligence, surveillance, and reconnaissance aircraft. So the only difference is that the pilot is sitting on the ground. He's inside a ground control station. He has a sensor and a weapon operator who are able to receive their data in near real time. So this kind of a platform with a technology going into a foreign country, when I say foreign country, I mean outside the United States, and goes into countries like India, Saudi Arabia, Taiwan, Japan, Belgium, UK, which has already got its first Guardian. Incidentally, it's called the Protector. So this has not been possible without the support of the local industry. There is a program called such as Blue Magic, which basically goes into that particular country where the platform is going to be deployed. It seeks out participation, it incubates, gives the seed money based on competition, and then selects that particular technology which is going to be adopted into the Guardian or the future UAV development as well as supply chain. So yes, sir, in answer to your question, I don't think that in today's world it is possible for an OEM to basically meet the end customer's requirements without having to do localization. Thank you.
Thank you for moderating this session in my absence. My sincere apologies. I had to just go out for a few minutes. I have a question for Boeing. In your opinion, is there a possibility for Boeing to consider emerging technologies or the futuristic technologies to come to India through the offset route? Or if you are already done it, can you amplify on that? And the second one is you have a setup at Devnali. It's coming up. Can you just throw a little bit more light on that? Are you going to have some futuristic technology there, or it's what?
So let me start with the second question first. We're coming up a big campus in the Aerospace Park in Bangalore, which will be primarily our engineering center, design and engineering center, and that will house more than 3,000 employees. And this is not just for the requirements that we have in the Indian industry, but it's for the globe. So if you have that scale of presence here in country, it has to be more than the basic engineering work. So absolutely, we will be definitely working over here in the futuristic technologies. There's already a lot of work going on in the AI/ML space, which is one of the things that we have been talking about. There's a lot of work on the IoT side, virtual reality and so forth. So that's going to be the main thing that will happen from that center. The first part was, can we bring the technology on the offset route? I think offset could well be an enabler, but I think what we need to understand is there is a necessity right now to have the technology to go to the next level. So in that concept, the answer to the question is absolutely yes. And we are doing it, in the structural world, where we have partnered with our supplier to come up with the FSTA route, which is a new way of doing structures with minimal tooling. Very fast, cost-effective, high quality. So yes, we'll continue to do that. And I was explaining in your absence that we run skill development programs here with the industry. We have our presence at the supply base. I have 200 team members here, most of them helping the suppliers here. So there is an absolute intent from Boeing side to be here and develop the industry base.
Thank you. My next speaker is from Big Bang Boom. Just a minute, please. He is Mr. Praveen Dwarkanath. He is the CEO, Big Bang Boom Solutions. Ladies and gentlemen, we need to compliment this company. This company has won 2 IDEX challenges in the recent past. Can you brief us on the innovative projects achieved by your company? And in particular, can you elaborate on some of the products like BN-based hybrid personal combat armor making a difference to our soldiers? Is nanotechnology going to be a thing which we all have to look forward in this area? I need your thought process on that, please.
Thank you, Commander Panwar. See, one of the things that happens is in an industry like ours, things are constantly changing. Now, the topic for the defense seminar today is futuristic technology for defense production. So one of the things that I would love to do is first understand what is futuristic technology. Anytime in the past, you've seen technology which has been breakthrough in nature. Think of something like maybe gunpowder being used for the first time, and your opposition is suddenly sitting on horses and their swords. Or you think of something like blitzkrieg tactics in World War II, where you have France that is sitting and just hoping for the stalemate at the Maginot Line, and you have tanks that break through the forests of Ardennes and just take over France in a matter of a couple of weeks. You then think about something like what Japan would have thought about towards the end of World War II, where they said, no matter what, we will defend our homeland. They trained people with sticks saying, we'll take our final stand over there. Suddenly, a couple of nuclear bombs are dropped, and it becomes a complete game changer. One of the things that we believe in Big Bang Boom is to try and envision the future. You can't always be right. But what will the next war actually be fought in? Research typically goes into 2 kinds of categories. There is fundamental research and there is incremental research. Incremental research is where you take existing technology, make it 5, 10, 15, 20% better, and suddenly you have a competitive advantage over your competitors and you sell your product at a premium. But where stuff starts to get very, very cool is when you end up doing fundamental research. Let me give you an example of fundamental research. When X-rays were discovered for the first time, nobody even knew how to apply it beyond a point. It was discovered semi-accidentally. But now the applications of X-rays are massive. That is fundamental research. Incremental research would be, I have a gun which is firing with X level of accuracy. Can I make it into X plus delta? Right. Every company cannot do pure fundamental research because it basically costs a lot of money. But in Big Bang Boom, one of the things that we will be doing is focusing some of our energies purely on fundamental research, developing technologies of the future way beyond what are the current requirements that are there from the armed forces. So when we were given an introduction, we were told that we're one of the first companies to win 2 IDEX projects. I want to just give a small update. We started this off in 2018. We won 2 IDEX projects in 2019. Both those IDEX projects are now production ready in Hall 1. So we would be the first company not only to win 2 in the beginning, but get them production ready in a matter of 3.5 years through COVID and everything there. A testament to that fact is, after winning those 2 IDEX projects, we have won 6 further grants after that. So that gives us our product pipeline going into 2023, 24, 25, and 26. Any of these projects that we have taken up, we typically get a requirement from the government. I'll not use terms, but there'll be requirements that will come in from the government which says, I would like A, B, C, D, E, F to be there in your product. The first thing that we did, and this is a call that we took in 2019, is saying, let us first ensure that these requirements are satisfied. That would be the basic thing. Second, benchmark ourselves globally. Third, look at features that we can put into the system that don't exist in global OEMs. See, one of the most important thing that is going to be going into the future, Atmanirbhar Bharat, production, all of that is fine. But if you control the technology, you control the keys to the entire puzzle. I think what India requires is not cost-effective solutions. See, nothing is cheap in defense. So instead of trying to be the cheapest player that is there or producing things at the lowest cost, I think there is a huge value add if you own the technology. If you own the technology, you can start fighting breakthrough wars. You can suddenly spring a surprise on the enemy, which they have no clue how to counter. We shouldn't be caught on the wrong end of the puzzle over here. So any of the technologies that we sit and we first develop before we even take into production takes into account futuristic war. So I can throw in terms, there is artificial intelligence, Internet of Things, but let's actually get down to what happens on the ground. When you're talking about artificial intelligence, you need data sets. What is your computer going to learn from? What is your system going to learn from? In the absence of data sets, how exactly are you going to implement AI? That, for starters, is a very, very difficult puzzle to solve. So any technology that we do, any trials that we do on the field, we ensure that our data sets are captured. We ensure that some common themes of technology are there across our product lines. So it's not just on one product that we do. So for example, AI will be there in literally every product that we develop. And the expertise that we get in from one product will be applied to the second one. Now you're trying to create a future-ready product. You need to integrate, see, AI cannot exist in isolation. It can't exist in the air. It has to be integrated with physical hardware. Now, engineers that we typically would recruit from some other field or get them fresh out of college, all of them will come in with a certain degree of expertise. The most important thing in this field is, especially in something like defense, you need engineers who have cross-disciplinary experience. What I mean by that is, if you have an electronics engineer, he can't say that I will work only on electronics. He needs to understand a bit of computer science, a bit of mechanical. We have people who work on things like botany, zoology. We have a product which is in naval deterrence. So it's a product that when it comes into contact with water, it expands about 10,000 times. And ideally, it's a non-lethal way of stopping a vessel at sea. So people who are working on that need to understand nanotechnology. They need to understand chemistry. They need to find a way to do production on an industrial scale. And why you need to understand botany is, at the end of it, if you put something in the ocean, it shouldn't harm marine life. So at the very least, you should understand the difference between lungs and gills. So when you're doing this entire thing, there has to be a way in which you develop an ecosystem of engineers who can work on cross-technology solutions. So that is something that Big Bang Boom specializes in. We like to pride ourselves in, one, imagining the technologies of the future, two, implementing them across product lines, three, getting a team of cross-disciplinary engineers who work not only on one project but across multiple projects, bring in the best practices and put it across different places. Now, you would have heard from the other eminent panel speakers about how it is very difficult to do everything within one factory. That's absolutely true. Controlling quality becomes a very important situation when you're dealing with vendor management and things like that. So we actually have a term for it internally in Big Bang Boom where we call it mini vertical integration. Okay, so what we do is we try and identify who our key vendors are. Okay, and whoever our key vendors are, we like to pick up a small minority stake in them. Okay, so it's like saying, you know what, you supply a critical component to me. If you have to supply a critical component to me, I would like to have some control over the supply chain, what is happening over here. I'd like to pick up a 3% stake in your company. Materially insignificant. That's not where I'm trying to make money from, but that's where I'm trying to secure my supply chain. I want a spot on the board. I want to be able to influence quality because that is the only way I can get my key technologies from outside. So when we get into production, the way we envision production is we will do production only of our core critical technologies. Things which are non-core to us, there are people who know how to do it better. We will vertically integrate with them using this many vertical integration methodology and take things forward into the future. The way we will be looking at things is, I'm not too worried about what the existing technologies are. This is something that will be our cash cow. It will give us money to invest into the future technologies. But we would like to be a company that looks into the technologies of the future, reimagine the future, take our bets over there, taking the money from the existing technologies, putting it into the future technologies. That's how I see defense production going into the future. Thank you.
I have one more question for you. I want to understand how much percentage of your revenue you invest into R&D, because R&D plays a very important factor in development of any technology or emerging technology. So as a startup, were you able to do that, or how did you achieve this?
So for starters, what percentage of our revenue goes into R&D? I would like to say about 80-85%. Okay, that would be a ridiculously high number for a more established company, but for a startup, that's all we do. We do R&D. We are an R&D company, right? So that's where most of our costs go. Now, the reason we've been able to do something like this is we've run a very lean ship. Okay, so from when we started off, we won these contests. We basically looked at this as a pathway towards finite research. See, research can be very open-ended. When you take a group of PhDs and you put them together, I mean, when they did their PhD, they did it over 5 to 8 years. That's typically how long a PhD takes. So they are not too worried about a 15-day deadline or a 30-day deadline or a 6-month deadline. To them, that's too short a period. But when you're looking at a commercial company, 3 more months can be the difference between a company surviving or a company dying. So a lot of things when you get into open-ended research, how exactly you would like to push things forward like this is, you start off by making each one of your researchers a stakeholder in the company. Like every one of our employees is a shareholder. Okay, so you take seminars with them on an unlisted company share price. How is that, relevant for an AI engineer? In a way, it tells him where his bread is buttered. He knows what he has to do in case he has to buy his next Merc. So one of the things I would love to see, and this is, essentially my dream within the company, more than me buying a fancy car, I find it very cool when any of the people who work with us buy something awesome. I ensure that I take a ride on that. So the way I look at things is, as the CEO of a company like this, the most important job description of a CEO generally is to take the share price up. I'd like to take my share price up in a sustained fashion. How I take my share price up is taking everybody into this entire journey as a stakeholder and pushing them towards that. In the future also, I don't see our percentage allocation to research going dramatically down. I'm not going to be investing into heavy capex and setting up massive production facilities because it's a different way of doing it. I would like to do better vendor management and getting my things integrated. Core technologies I will keep in-house, but everything else, which I consider non-core, I would like to just develop an ecosystem around me. And through this design journey, my partners have been with me. So when they've been with me through the design journey, suddenly the production journey becomes a lot easier. Because getting that first piece out is tough. Once you've got the first piece out, beyond that it's a question of scaling. We have some expertise in manufacturing, and I'm sure we'll bring that to the core as well. But just to answer your thing in one line, sir, I think R&D is key to what we do, and we want to be the OEM. We don't want to tie up with OEMs and do TOTs and do all of that in India. There is a place to that. There are a lot of places where we utilize that as well. But our vision is for us to be the OEM and be the OEM that is imagining the future. So I think that is where it is more relevant to us. Thank you.
Well, ladies and gentlemen, that is Big Bang Boom. I would request each one of you to please give a big hand of applause to him. But before I go to the next speaker, I have the last question. How did you come to this term Big Bang Boom? Because this is something which, generally it is in the comics. How did it come to your mind?
Wow, that's an interesting question, but so let's look at it this way. We have a panel discussion here. I'm the only guy dressed in a t-shirt and jeans. Okay, so let me put it this way. If you're looking at reimagining defense, at some point you need to have fun at your job, right? So when Shiva and I started this company off, we looked at it saying, how is it that we're going to look at this in the future? You have the stock markets, you have companies listed on the stock markets. For example, if you take Infosys, its stock market ticker would be INFY, INFY, right? So the full name doesn't come in. When we get listed, our stock market ticker will say boom, okay? So we thought it was a great name. We like to talk about this as a defense industry, right? So if somebody is attacking us, we like to defend. But hey, there is also offense, right? So I thought the name of the company should reflect what we do. And when you say Big Bang Boom, it's very clear what we do. Okay, so there's no ambiguity in what we do. A bit of fun, a bit of looking into the future, a bit of crystal gazing, but that's what we are as a company. Thank you.
Well, that's Praveen. Once again, a loud applause for him, please. The last speaker in the panel is Mr. Ashish Sharaf. He is the Vice President and Country Director, India, Thales Group. Sir, would you give your perspective on the futuristic technology vis-a-vis the industry, Indian industry? How good or how adaptable are the Indian industry to adapt to the futuristic technology? That is question number one. And the second is, now with the launch of 5G in India, in your perspective, how do you see the Indian defense ecosystem eager to absorb this technology in, say, Internet of Things, AI, cybersecurity, vis-a-vis the global scenario? Over to you, sir.
Okay. So before we begin, just an introduction. So my name is Ashish Saraf. I am the head of Thales in India. Little bit about Thales. So Thales is high-tech, deep-tech company specifically present obviously in aerospace, defense, and other domains, mainly in mobile computing, digital, cybersecurity, AI, analytics, banking, and so on and so forth. We are a member of the Rafale family. From a futuristic technology standpoint, two things stand up. One is the active electronic surveillance array for the Rafale aircraft itself is built right here in India with our JV. And it's not only built for the India Rafale, but it's also now getting exported for the world's Rafale. That in itself conveys how the superior technology that number one we are deploying for the Indian equipment and the Indian Rafale is also now not only built in India but exported out of India to be fitted onto the world's Rafales. Second is the self-protection suite of the Rafale is again made here, right here in our country, and is exported out to for fitment into the Rafales of the world. We have two massive engineering centers doing research as well as engineering on many aspects of futuristic technology, starting with AI, starting with human-machine interface, which reduces the amount of displays required in an aircraft or a helicopter pretty much down from many to one, giving an intuitive display to the navigator and the pilot to actually maneuver this aircraft. Now, beyond this, the wars of the wars of today, and in fact also the future, right? They will be mainly fought with not with arms and guns, but it'll be mainly fought with intelligence. Every equipment that is being used and deployed across our armies today and navies and air force is intelligent. The amount of data it receives, transmits, and makes a decision based on the amount of data that it transacts. There is immense amount of intelligence built in it. It starts with drones, manned, unmanned vehicles, not only in the air, but on water and even underwater. And the amount of sensors that are used, underwater, in the air, as well as on ground, today is unprecedented. Thales is obviously at the forefront of this, doing deployment, manufacturing, as well as research in all these areas, in country, research, manufacturing, as well as utilizing this for export purposes across the world and so on. So, from a standpoint of the second question that on 5G, right? The amount of data that's exchanged today between various systems in a battlefield management systems is unprecedented. There is a video feed coming in, there is a positional information, there's information on the weapon itself that it's receiving these to act. We have an attachment that goes on a gun. It basically just the viewer, by looking at the video feed that it's getting and the target the soldier wants to aim at, it actually tells him the probability of hit and at what point should he press the trigger so that the probability of hit is maximized. It's available and it's of the size of probably a pen that goes on a gun, right? Two sensors that actually are space-based that are communicating with the battle management system that is deployed across the battlefield. Everything includes a sensor that processes data. And what 5G does is it effectively eliminates the latency between all these systems. I mean, imagine a soldier in a battle wanting data and getting data about even 0.1 seconds later where he has to fire. It makes so much of a difference. What 5G does is it nearly eliminates this condition and has a real-time data exchange mechanism that is built between the system or the system of the systems that are talking to each other, right from air to ground to at times space, and the moving elements on the ground that are mounted on the trucks, the soldiers, etc. And similar thing, on water with the navies and so on. So today, the adoption of 5G in defense, is just getting started. From an India standpoint, we are just looking at virtual private networks to be built in and hopefully deployed across the borders or in a battlefield situation, which could be mobile. So we are now looking at deploying battlefield management solutions which are effectively mounted on a truck, which uses the 5G technology, creates a VPN across a small area, and allows the entire machinery from ground control to air to surveillance to soldier, and to have a coordinated battlefield management systems that actually enhances the effectiveness of battlefield multifold in a situation where everything needs to be coordinated from air to ground to the movement and so on. So these are some of the examples of technologies that we are bringing in, we pioneer. Some of them developed right here as part of our engineering and technology centers, not only for India, but for export and so on. And this is just the beginning. As the fields and the equipment and the sensors, they receive more data, they get smarter. Again, 5G plays a major role in it. The video feed that happens, the information and the amount of information based on the actions that it gets processed for the system to learn and again feed back into the people in the battle, including the soldiers. It's getting smarter and it's getting smarter as the technology emerges. Bake in that AI and ML algorithms, we are looking at a system that is incredibly intelligent, effectively making its own decisions or minimizing the human intervention to have effective decision making. It's something that kind of holds into the future as far as our defense and smart defense management systems are concerned. We at Thales, we kind of are the providers and integrators of all these and much more in terms of deployments. We do that across many countries and are also in the process of doing that here, specifically in some domains, including for the ground forces and also for the space. And this investment from us will continue as part of our efforts to enhance our footprint in India. We've been present here since 1953, over 2,000 employees, 2 JVs, 47 different supply chain partners, and growing, and having a large R&D space where we do research on human-machine interface, flexible test benches, which will reduce the amount of investments required in production as well as test equipment, many folds. And some of these things we kind of plan to continue to do so. So I hope that answers your question, and thank you so much.
Thank you. I have one more question for you. What are your thoughts on India's preparedness in cybersecurity? If you can throw some light.
So this is a domain that we come across every day, either in a positive or a negative fashion. I mean, 2 days ago, there was a news that the grid of, there was a cyber attack on Tata Power. And if we imagine the scale of something like this, the effect could be extremely negative, and we see these on a daily basis, exchanges getting hacked and so on. So the need is clearly felt. In terms of defense, it does not just include the forces. We tend to be strong believers in the fact that when we talk about defense in cybersecurity, it starts with protection of national assets, airports, critical infrastructure, infrastructure even that includes industrial infrastructure, like refineries, like our industries, manufacturing units, crucial infrastructure like airports and so on. So a comprehensive cybersecurity framework and thought needs to be applied at a national level, which just does not include just the pure defense establishments, which obviously are the first lines of defense for us in terms of getting protected. So it needs to percolate down to the very last amount setup and the infrastructure that we would like to protect. In terms of adoption, I think there is significant amount of awareness that has already taken place amongst all the stakeholders that actually work on different domains to see how can we best protect our assets from attacks and have a strong cybersecurity protection infrastructure. At a policy level, we do need some work. This is an emerging field. It changes daily, as many of my colleagues have pointed out. And from an adoption standpoint, we've already seen a lot of progress being made in terms of asset infrastructure protection, in terms of protection of many infrastructure bases, networks, etc., that are owned by our forces. And from an adoption standpoint, I think we are starting to be, I'm not going to say world leaders, but heading towards that direction where we have implemented some strong measures to detect and prevent and to take proactive measures where we probably need to be slightly ahead of the so-called attackers. The best defense in this situation is to be way ahead of the attackers, right? And as long as we continuously preempt proactively some of these issues, I don't think we will face too much of adversities in terms of these particular attacks. So today the adoption has started. We are well on our way for not only adoption but also foreseeing some of these attacks and foreseeing some of the measures that need to be taken. But it's a continuous process. It's a continuous process where if we stop at some point and say, yes, we are cyber protected, I don't think that that would be an end goal. It's an ongoing continuous process that needs to enhance every day, and this is what's required for us to be kind of ahead and then eventually be the world leaders in this space.
Thank you. Ladies and gentlemen, that is Mr. Ashish Sharaf from Thales. Big round of applause for him. We have discussed in this panel. Now I open it for questions from the audience.
Good morning, panelists. A lovely discussion over here. I'm Colonel Kevin D'Souza. I'm a researcher from IDSA, now retired, and I've written a book on transfer of defense technology to Indian firms. I've been looking at the industry for the last 5-6 years now, and we're compiling a kind of complete holistic understanding. So very interesting over here, we have Big Bang Boom, which is a company just maybe around 2-3 years old. You have Thales, which has been here for around decades. Big Bang Boom says that they collapse the complete process from fundamental research to production, which I believe, as per the TRLs, right, technology readiness levels, he's taking it through all those steps in just a short period of time and being able to deliver it. Whereas what I have seen is in the US and the West, you have so many layers. You've got fundamental research where the government funds and the risks are very high. Then from there, you move on to applied, and then prototyping, and then actual product development, manufacture, etc. So what I would like to know is, from Big Bang Boom, is that fundamental research normally is not something which defense companies or production companies take on, because the risks are so high and it's so vast. It's so how does it work? You said finite research. Could you explain a little bit more on that?
Sure. You're right. Fundamental research is something that most commercial companies don't take on, because fundamental research by its very nature is to be done by academia. And once in a while you have some breakthrough thing that comes out and then you're able to monetize it. Typically, industries where I see some amount of fundamental research happen, even on a commercial scale, would be the pharma industry, where you would have, say, new molecules developed all the time, new techniques coming out all the time. So that would be a classical industry where you have it. And we try and take best practices from what happens in an industry like pharma and taking it into something like this. If you take an industry like pharma, you would have researchers who would be working on breakthrough technologies, but they would be given milestones to achieve at any point of time, saying, you know what, we will try milestone A. If it works in 6 months, great. If it doesn't work in 6 months, you move on and try and do something else. So as a company, if our starting point wouldn't be fundamental research, our starting point would be probably sitting in a boardroom and imagining the technologies of the future. Now you'd say that, okay, this is what I think the technology of the future should be. Now, among this solution, these solutions that we are looking at, what will my existing technologies provide me as a platform? Then you look at what is the delta. You say, okay, these are things that we've not worked on in the past. We don't know how this is going to work. Existing technologies don't exist. So what is the easiest way to target it? That is where we'll reach out to the Indian government for assistance. So if you look at the IDEX programs which have come in, they've come in with a lot of support. So typically people look at the IDEX programs as a 1.5 crore cash grant. To me, that is the smallest part of the puzzle as a part of the IDEX grants. The IDEX grants come in not only with the 1.5 crore grant, they come in with testing facilities and a holding hand from the armed forces. So any of these things that we want to try, trying it through the process of grants as opposed to doing standalone fundamental research is a huge game changer. So what happens over here is, like, I'll give you an example of that naval deterrence that I had explained some time back. If I were to do fundamental research on a material, trying to develop a polymer from scratch, which would do something like this, I would need access to, say, a boat. I would need access to testing facilities. I would need access to people who do this on a real-time basis, who'd be willing to lend their time to me. But when I do it as a part of the IDEX grant, suddenly the boat is not owned by me. The people who are operating the boat are not employed by me. The number of testing parameters that I require to do, incremental research while I'm doing fundamental research here is very different. So the material I'm starting out to develop, I know that this material needs to have this level of a viscosity, it needs to have, the ability to have this level of cross binding and things like that. But I don't have to develop all of that from scratch. I don't have to have all that infrastructure from scratch. So what I do is, step one would be reimagine future technology. Step two, identify existing technologies that will fill in the gap. Step three will give you the delta. Once you know what the delta is, basically run a scanner and see if you can get a grant that will fill in that. Of course, the cash helps, but what comes in as a part of a protective mechanism around it is, it puts you in a wonderful cocoon where the ecosystem accelerates this fundamental research. Now, I'm not trying to say that this will be successful in every scenario there is. So you're right. So taking something through from inception to, say, TRL level 7, forget TRL level 9, would still be a massive significant challenge in itself. So that is where you pick your battles. So you say that, this is something where I have expertise in. I have wonderful relations with academia. I'm basically 13, 14 years old in my professional career. Okay, so I finished engineering and an MBA and worked in the corporate space for about 3 years. The first startup that I did with Shiva is, like, you have Byju's and you have White Hat Junior today, which teach kids how to write, how to do coding, and develop basic apps, things like that. We started off saying, let's teach students how to write research papers, how to file patents. So we have this wonderful network that exists across academia, that exists with research labs across the country. And we tap into that network for getting us the best level of updated research beyond this research papers, HR people who come and join us, so on and so forth. So that gives us a significant boost over others in doing research. So I hope I've answered your question that way. That's where it would differentiate us. Thanks.
Thank you. If there's any other questions from the audience? Can we please pass the mic?
I'm Sanjay Bhagat. I'm from QRL Bioscience. So basically, I heard that we are hearing about the futuristic offense and defense using the aircrafts and big things. But recently, we realized that there was a virus attack affecting the whole world. So I have not heard about the technological preparedness, either defensive or offensive, on biological or chemical warfare or in kind of things like that. Thank you very much.
Anyone in the panel would like to answer? Because I think the opening statement by Ms. Preeti Patel, she did mention about biological technology in the biological field. Yes, it is emerging, and it has been right from the the First World War, Second World War. You will see nerve gas, all these which are there. As far as your question regarding the virus being biotechnology weapon, are you trying to say that way? How? No, there is no conclusive thing.
No conclusive, I'm not talking about.
Yes.
So now the biotechnology has gone into that level wherein people know how the life works. At a molecular level, it is known. So what we are still talking about is defense in the sense of what it happened in the Second World War in the hundreds of years. But for sure, we know there are science proven that you can actually modulate the behavior of human by affecting some certain kind of virus, let alone attacking and doing all those things. So do we have any kind of, I mean, we work on that field. I mean, so I'm not working in the defense sector. So I am working in the field wherein we develop certain kind of therapy for certain conditions. So I'm just curious to know, do we have any kind of thought like that?
Okay, maybe from the defense perspective, let me just share with you. We have laid out a vision 2050 as per the requirements told by the Honorable Prime Minister. And in Vision 2050, we are envisaging every type of aspect, right? We already have in place for the NBC, nuclear, biological, chemical, from a large amount of time, many years, ongoing programs, counter programs towards that. And when we have coined the Vision 2050, we have included each and every aspect. But today, forum is very specific for futuristic technology for defense production. Maybe that is why you never got the views of any of the panelists with respect to your question. But yes, from defense perspective, we are working on it. And if you're working in that field, I'm sure you'll find someone who will be in tune in sync with your thought process, and you can share your thoughts with them. If you have something specific, you can always let us know separate from this forum. Thank you.
So maybe I could just take 30 seconds on this question. I think when you're talking about chemical or biological weapons, more than having a straight counter to them after they have been administered, I would like to take one step back. You need to be able to deliver these weapons. So there are vehicles that deliver these weapons. So a lot of solutions are coming up. For example, we have an anti-drone solution that we are doing internally, which you can go check it out in hall number 1. So there's a lot of technology that's being played on how do you stop this delivery from taking place in the first place, rather than what you do after it has been delivered. So in a bit of a prevention is better than a cure kind of a situation. So that is stuff that we've been working on, but in terms of after it has been delivered, that's not something that we are doing right now.
Is there any other question?
One. We'll take in last few questions. So.
Okay, I'm Air Vice Marshal Ajay Shukla, and I head the Information and Communication Technology Vertical in Headquarter Integrated Defense Staff at Delhi. But my question actually is not to the core part. Since I heard the word offset, this is something that has been plaguing my mind. I've been in the procurement of the plants branch in Air Headquarters for years and have been a part of certain procurement processes, seen through the offset drills, and the bit of a despondency that prevailed on while we were inking various offset contracts is basically just trying to meet the numbers and somehow, and we all are aware of pretty sad offset story. Am I right in assuming that whatever little bit of niche structures or production, etc., that various The big players in the, from abroad are doing, making certain empennages, some parts of the aircraft, they are made here in India. These are all started as part of meeting that offset requirement, somehow fill in the blanks there. And today we are reached somewhere, but small parts being made here, yes, good, sent back and, all the way from, and then the rest of the aircraft is built and all. What is really stopping us, stopping you all from going the C295 route? You have full aircraft, etc. And sees what cost of production here is low, ecosystem is there, government is holding your hand. So what is stopping you from building full, full platforms, machines, birds, and I really would want to know why these baby steps. I still consider them as baby steps. Or am I missing something in this entire thing? And maybe that perhaps is the right way to do. You first make one tailpiece or some door of a Sikorsky or something, and in some 10 years' time, maybe start making left side fuselage and then move on. What is really, why is this process slow?
Sir, you mentioned empennages, so I picked up the mic, but just wanted to clarify that Lockheed Martin did not come here initially for offset obligations to check the box by any chance. Actually, there was no vision. It was Chairman Emeritus from the Tata Group, Mr. Tata, and the leadership at Lockheed Martin that got together and decided that it would be a good way to actually emerge the aerospace and defense industry here. And that was really the impetus, the initiative. So it was an opportunity that Lockheed Martin saw in terms of quality that I spoke of, and the quality of the skilled workforce, and the quality of the products that are developed here that could be shipped at an affordable cost back to US. However, after that, yes, there have been some offset investments to further our technology, which is what I was referring to, that we have always looked at being future ready, not looking backwards in the rearview mirror, saying that what more technology do I need, regardless of volume, so that we can actually increase the ecosystem's capabilities here within. As far as your direct question about what does it take to move the entire aircraft to the C295 route, as you might know, the C295 was not something that happened overnight. It took years as well. So given that these are like ocean liners that take a long time to turn, I personally believe, this is me talking now, that we are definitely headed that way with all the OEMs thinking of what more can we do. And definitely it'll be a G2G discussion more so, that will be led by industry leadership. But I do not see it as an overnight decision that can be done because we are still within India, an emerging industry on many fronts. In many cases, we have experts. So that would be my take, if you will.
So, please.
Okay. So you talked about a poor offset story. I hope you're not including Boeing in that, because we've been the leaders in fulfilling the offset obligations in country. It said that from the supply chain point of view,
So I would like to, stop you in the middle, because we have our Honorable Raksha Rajya Mantri, Shri Ajay Bhatt ji, Ministry of Defense, Government of India present here. Can we have a big round of applause for him? जी सर, आप आगे आके यहाँ पे बैठ जाइए सर, ये कंप्लीट कर लेंगे फिर। आप पूरा करिए, छोड़िए। Sure sir.
Yeah, so the only thing I was saying, while offset is important, I think from Boeing's perspective, we think offset can at the best be an enabler. But if you look at what we have done in country is outside of offset. because you cannot have a sustainable supply chain if you do it only for opposite reason. So we are sourcing parts from India because we see value. And value could be in terms of the quality of parts, the cost, even technology and innovation. So I think, and going back to the question of how do we grow in the value chain, we are doing Apache fuselage here, which is one of the complex parts. So unless you have a mindset that you'll assemble the products here and import everything from outside, I think the safest route is to develop the broader ecosystem. And what we have done in Boeing is gone beyond structures, wire harnesses, panels, forgings, thermoplastics. Now we're building that ecosystem, and that will lead into maybe fulfilling our ambition of building an aircraft here in India.
Thank you. If there are any other questions, we would request you to please kindly take it offline, as time is pressing. I would like to thank our moderator and all the panelists for this amazing session. Moving on, for the special address, I would like to request Air Vice Marshal P.S. Sareen, VSM Assistant Chief of the Air Staff Engineering A, Indian Air Force. So I would like to request you to please kindly address the gathering.
Honorable Minister of State for Defense, Shri Ajay Bhatt, esteemed panelists, and learned audience which is here today. It's been a proud privilege for the last 2 hours to participate in this panel as the end user's representative and learn the views of the industry on how we are moving forward, establishing an ecosystem. There have been a large number of very, very apt questions which have been put to the panelists, which has shown us the roadmap for a self-reliant and truly Atmanirbhar Bharat, the task given to us by our Honorable Prime Minister. We in the Indian Air Force have also put together a roadmap on how we are facilitating the process. There is very, very importantly the manufacturing aspect, the futuristic technology-ready weapon platforms and systems, induction. The Indian Air Force has been advocating self-reliance, as is very evident from the support given to the LCA program, going on to the Mark II, and also the futuristic AMCA. I'm sure a lot of the learned panelists here who represent joint ventures and ventures with a large number of foreign OEMs who are dealing with latest advanced technologies have also recognized the aspect that the only way forward is not only built to print in India, but also designed to print in India, which is what has been forthcoming during the discussions here. From the Indian Air Force perspective, we're also looking at support of our existing platforms, and that is where indigenization holds the key. When we say indigenization, we do not limit indigenization to manufacture of replacements, but as brought out by some of the speakers, we are also looking at that extra edge or the delta addition. The delta addition in size, weight, and performance, so to say. We got Big Bang Boom expressing how the delta can be brought forward. We're looking at the delta now into the manufacturing. We're looking at the new processes identified and some light thrown by some of the speakers, which will help us. We are already into 3D in a big way. 300 plus parts have been manufactured using 3D. The Air Force has taken the lead, held country-wide seminars on how additive manufacturing and 3D can be a game changer in the process. We are looking at COTS-based open architecture adoption framework for development of avionics. So these are certain aspects which we have already taken the lead, and I'm sure whatever we have learned here, we will utilize. From the industry perspective, we are supporting MSME in a big way. The government has brought a lot of initiatives DRDO, almost 25% of the R&D funds are also now going to be put into research. You heard the advantages of the IDEX platform. Similarly, there are various other initiatives which the Indian Air Force is capitalizing on. The Make initiatives also, as well as the Technology Development Fund of the Indian Air Force. And I'm sure during the course of the Defense Expo, you have also been exposed to certain aspects of certification. And here I would just like to add one point from my point of view. When we look at the disruptive digital grid of technologies, we lose sight of one very, very important aspect. And that is how to use the immutable force of blockchain in ensuring that the digital twin, which we capture right from the design phase, that is cradle to grave, can be effectively utilized to harness not only data, use that data in analytics, AI, ML, all those aspects as already spelled out the speakers. But if we put blockchain at the back end, we can do away with numerous audit processes. And I'm not referring only to financial audit. We're also referring to the very important audit practice of certification and regulation. So if we adopt blockchain right now from the design phase itself, we will have immutable records in place, self-governance towards meeting the certification, and regulatory aspects will also come into being. With these few words, I once again thank Associated Chambers of Commerce for this opportunity and for helping us to achieve our aim of a self-reliant India. Thank you very much. I am also honored here to welcome the Honorable Minister of State for Defense on behalf of all of us here, sir. Today we welcome you, and we are very proud to be part of this gathering here from the defense side, and also I'm sure from the industry perspective. So welcome, sir.
Thank you, sir, for the insightful talk. अब मैं आदरणीय श्री अजय भट्ट जी को बुलाना चाहूँगा, सर, अगर आप आके एक दो शब्द on the futuristic technology and defense production पे हमारे लिए बता सकते हैं, सर. Thank you. Ladies and gentlemen, please let's welcome him with a big round of applause.
श्री प्रवीण दारकनाथ जी, श्री प्रतीश गांधी जी, कमांडोर अजय पवार जी, एयर वाइस मार्शल PS सरेन जी, श्री अश्वनी भार्गव जी, श्री किरण डम्बाला जी, श्री धवल रावल जी, श्री आशीष सराफ जी. मित्रों, बहुत सारी चीज़ें आपको ज्ञात हैं, क्योंकि आज कोई चीज़ कहीं भी छिपी हुई नहीं है. हर एक को क्या हो रहा है, कैसे आना चाहिए, पहले क्या था, अब कैसे हैं, इसका पूरा ज्ञान है. आज हमारे संचार माध्यम इतने उन्नत हैं कि चाहे हम अंग्रेजी को देखें, हिंदी को देखें, जो जिस भाषा में देखता है, या फिर लोकल लैंग्वेज को देखें, कोई ऐसा न्यूज़पेपर नहीं है जो डे बाय डे अपडेट नहीं करता हो, कोई चैनल नहीं है जो डे बाय डे अपडेट नहीं करता हो. हमारी मैगजीन से हैं, आर्मी की मैगजीन से हैं, साइंटिफिक क्षेत्र में काम करने वाले लोग अलग से क्या क्या हम लोगों ने इनोवेशंस किए हैं उसके बारे में बताते हैं. बहुत सारी चीज़ मैं अभी आपको सुन रहा था, काफ़ी अच्छी चीज़ें आपने बताई हैं, और बहुत सारी पहले के जो यहाँ पर विद्वान हैं उनको मैं नहीं सुन पाया, वो चीज़ें भी हमारे सामने आ गई होंगी. हमें जो रक्षा उत्पादन के लिए भावी प्रौद्योगिकी विषय पर बोलने को कहा गया है, आप सब जानते हैं कि जब प्रौद्योगिकी हमारी उन्नत होगी तो उसके बाद ही हम कहीं आगे को बढ़ेंगे, हमको नॉलेज हो जाएगी किसी भी चीज की। और ये तब होगी जब हमारे आविष्कार होते रहेंगे। जैसे डीआरडीओ करता है रक्षा क्षेत्र में, कई प्राइवेट हमारे और भी कई लोग हैं जिन्होंने कई चीज़ें डेवलप करी हैं। कुछ चीज़ें ऐसी हैं कि हमको बाहर के लोगों से भी थोड़ा सा सहायता लेनी पड़ी है। मैं अभी यहाँ गया था आपके बबीना में, तो मैंने के बजरा जब देखा तो मैंने कहा आप मुझे डिमॉन्स्ट्रेशन से समझाइए कैसे इसमें क्या क्या चीज़ें हैं। उसे भी देखना पड़ा। आप सबको पता है कि कुछ हमारा भाग है, कुछ हमारे मित्रों का भाग है। एक किस्म से वो भी एक बड़ी ऐतिहासिक चीज हमने बनाई है। अभी आपने देखा तेजस फाइटर हमारी एयरफोर्स ने ले लिया, तो एयरफोर्स में जब आ गया तो हमारी चीज है। अभी आप हेलीकॉप्टर का जिक्र कर रहे थे, वो मैंने नोट भी किया होगा इसमें। तो ये सारी चीजें प्रचंड वो हमने ले लिया। मैं अपाची को देखने भी गया। आपका पठानकोट पे अपाची पे बैठा, उसमें हमारी बेटी पायलट थी उसकी, और सारे सिस्टम को देखा मैंने। कैसे आपके हेड से आप यूं घुमाएंगे जिधर को, वही नीचे से बंदूक निकल के उधर ही जाएगी जो नीचे लगी है। कई चीजें सीखने की होती हैं, ये टेक्नोलॉजी है। और सेम टेक्नोलॉजी लगभग जो प्रचंड आया है उसमें भी है। कितने नीचे तक आप जाएंगे जो रडार पकड़ न सके, कैसे आप दुश्मन को बर्बाद करेंगे, ये सब एक के बाद एक प्रौद्योगिकी जो हमारी निकली हुई है टेक्नोलॉजीज, तो उसके बाद हम यहां तक बढ़ पाए हैं। देखिए, मैं कल जगह जगह इस बात को बता रहा हूं कि अगर मैनेजमेंट ठीक नहीं होगा, चाहे आपका घर का हो, आपने कोई प्रतिष्ठान खोला हो उसका हो, आई मीन टू से फैक्ट्री वगैरह, और या हमारी आर्मी हो, तीनों हमारी सर्विसेज हैं कहीं पर भी, और या जहां कहीं भी आप अन्य प्रकार के कोई व्यावसायिक प्रतिष्ठान खोल रहे हो वहां हो, अगर वहां का प्रबंधन ठीक नहीं है और यहां से अंदर से कुछ करने की इच्छा नहीं है, तो आप प्रौद्योगिकी के लिए भी नहीं कर पाएंगे। मैं जगह जगह बताता हूं कि आपके बगल में श्रीलंका है, दूर नहीं, हमारा मित्र है, लेकिन लोकतंत्र का सबसे विभत्स सीन आपने वहां देखा होगा कि वहां के जो प्रदेश के मुखिया हैं वो भाग रहे, उनके पीछे जनता पड़ी है। बाद में उनके बेडरूम तक जा रहे हैं, बिस्तरा जो लगा है उसमें कुछ लेट रहे, कुछ बैठ रहे, फोटोग्राफी हो रही है। उनकी जो चेयर है वहां की कॉन्स्टिट्यूशनल पोजीशन की चेयर, उसमें अपने फोटोग्राफ कर रहे हैं। उनके जो बाग बगीचे हैं उसमें घूम रहे हैं और उसमें डुबकी लगा रहे हैं, जो उनका वहां पर स्विमिंग पूल है। क्यों हो गया ऐसा? कोई कारण तो होगा। क्योंकि जो पॉलिटिकल विल थी, नेतृत्व था, वो नहीं देख पाया। चाहे हम कितना कहें कि कोरोना ने मार डाला, इसने मार डाला, इसलिए और देशों में भी तो हो रहा है। जो लोग ठीक तरीके से नहीं चलते, ये मेरा है, अब ये सरकारी बिल्डिंग है, मकड़ी का जाला है तो जाला रहेगा। कहीं अगर छिपकली रेंग रही है तो रेंगती रहेगी, घर में आएगी तो एक बार हम छिपकली को भगाने का प्रयास करेंगे, मकड़ी का जाला साफ करेंगे, क्योंकि ये मेरा है। अब कहीं नल खुला है तो नल खुला ही रहता है। इधर तो हम भाषणों में कहेंगे, स्पीच देंगे, चाहे हिंदी अंग्रेजी कुछ भी बोलें, सेफ वाटर, पानी बचाओ, पानी का ये है, उस पर लेक्चर पेल देंगे 1.5 2 घंटे का, लेकिन बह रहा होता है, बहते जाता है। बिजली जल रही होती है, जलती रहती है। तो जिस दिन ये हमको ये लगता है कि ये मेरा है, ये सब कुछ मेरा है, तो अपने आप हम करते रहते हैं। जो हमारी आवश्यकता है आविष्कार की जननी है। हमको कहा गया है भाई जो आवश्यकता होगी उसके लिए हम प्रौद्योगिकी को डेवलप करने के लिए रात दिन लगे रहेंगे। आज डीआरडीओ इतने काम कर रहा हमारे बीच में, अन्य भी हमारी प्राइवेट जो हमारी लैब्स हैं वो देख रही हैं। आपने देखा कोरोना के दौरान में कैसी कैसी दवाई हमने बना दी। तो तभी हम प्रौद्योगिकी को आगे ले जाते हैं जब यहां से रात दिन काम करने की लगन हो। और वो मूर्त रूप तब आता है जैसे अब तेजस बन गया, कोई तो प्रौद्योगिकी लगी होगी, प्रचंड आ गया, कोई तो लगा होगा, हेलेना हमने बनाया, कोई तो प्रौद्योगिकी हमारी कहीं ना कहीं हुई होगी, कोई ना कोई आविष्कार तो हम कर ही रहे होंगे, तभी तो आज लोगों में जा रहे हैं, हमारी डिमांड ज्यादा बन रही है। अब ब्रह्मोस है, चाहे रशिया के साथ हमारा ठीक है हुआ उसमें आज से कई साल पहले, लेकिन अब यंत्रतोगत्वा वो हम निर्माण कर रहे हैं सब कुछ, आज उसकी मांग बढ़ गई है बाहर के लिए, कुछ तो कर ही रहे हैं हम लोग। तो इसलिए प्रौद्योगिकी और ज्यादा उन्नत हो जाती है अगर आपको यहां से कोई हुक उठती है। लगातार जो साइंटिस्ट हैं रात दिन खपाते रहते हैं, कई लोग तो वहीं टेबल पर स्वाहा भी हो जाता है उनका, घर बार कुछ नहीं, एक ही रटन रहती, इसको आगे कैसे करना है, इसको उन्नत कैसे करना है, ये सारी चीजें होती हैं। हमने आज एक्सपोर्ट में एक रिकॉर्ड बना दिया है, 560%, 560% तक हम आगे चले गए हैं इस बार। हमने इसी साल में अभी हमारा ये वित्तीय वर्ष जो फाइनेंशियल ईयर है समाप्त होने में समय है, 13,000 करोड़ के एक्सपोर्ट अभी तक कर दिए, पिछले को नहीं कह रहा हूं। अगर 38,500 के इन 7-8 सालों के देखें तो हम 50,000 से आगे चले जाएंगे अगर उसको भी मिलाएं तो। ऐसा कभी नहीं हुआ पहले, आज आगे बढ़ रहे हैं, लोग आज हमारी तरफ देख रहे हैं। मैंने कल श्रीलंका के बारे में जो बताया, उनकी जो मैनेजमेंट थी वो खत्म हो गई, उस ओर ध्यान नहीं आया, अपने को देखने लगे, अपने परिवारों को देखने लगे, जो जहां था वहीं देखने लगा, बैठ गई प्रौद्योगिकी, क्या देश ही बैठ गया। उस समय और भी बहुत कारुणिक दृश्य था कि उनके रक्षा मंत्री से मेरा इंटरेक्शन था, अभी हमारी आज भी होने वाला है युगांडा समेत 5-6 देशों से, और इसके बाद माननीय आरएम साहब का भी कई देशों से होने वाला है, हम लोग बैठते रहते हैं उनके साथ। तो वो उन्होंने हर डिमांड दी हमको, कहा पैसा नहीं है। और आज एक बहुत बड़ी चिंता का विषय है, पड़ोसी देश की स्थिति ये हो गई कि उनके जो यहाँ पर हमारे एनडीए या जहाँ भी ट्रेनिंग लेने आते हैं उनके पास आने के लिए किराया नहीं है, और उन्होंने यहाँ हमको कहा है कि हमको इस साल ट्रेनिंग दे दो, जब हमारी सरकार के पास पैसे होंगे अगले साल हम दे देंगे। कितनी बड़ी स्थिति खराब हो रही होगी। जो प्रौद्योगिकी थी वो भी बैठ गई, और आगे कोई आप उसका फिर से प्रयोग कर रहे होंगे या बढ़ा रहे होंगे, ये सोच से भी बाहर है। तो सबसे पहले है कि प्रौद्योगिकी को कैसे बार बार बढ़ाएं, हमारा मैनेजमेंट ठीक होना चाहिए। और मैनेजमेंट का उत्कृष्ट उदाहरण देखें तो भारत है, 130 जनसंख्या का देश, 130 करोड़, और उसमें भी आप एक बात को गौर से देखिए कि कोरोना में अगर आग लग जाती तो कितने मरते हम, आर्थिक स्थिति कैसी लड़खड़ाती, लेकिन हमने संभाल के रखा है। अगर कुछ नहीं भी होगा हमारे पास, आप आर्थिक मापदंड भी जानते हैं, आप देखिए उसके अंदर 1 साल तक कुछ भी नहीं होगा तो हम अपनी सारी जनता को सम्मानजनक तरीके से भोजन करा सकते हैं। ये स्थिति हमारी है आज। ये सब नई नई प्रौद्योगिकी भी है, नया उत्साह भी है, और यहां से समर्पण भी है। अब आज आप देखते होंगे आत्म सम्मान, आत्मरक्षा जो चीजें होती थी, उसमें आ गया आत्मनिर्भर भारत। लगातार और लगातार आज सबके अंदर एक बात है, हाँ यार हम आगे बढ़ रहे, हाँ हम आगे बढ़ रहे हैं, हम आगे बढ़ रहे हैं। आज हमारे बॉर्डर चाक चौबंद हैं, हमारी सीमाएं, हमारी टनल खुद गई हैं, ये भी एक प्रौद्योगिकी है हमारी। ब्रिज बन गए हैं हमारे, सबसे ऊंचाई पर इंडिजिनस बन रहे हैं। अभी हम जो टनल वगैरह हुए हैं इससे 7 करोड़ रुपए पर डे बचा रहे हैं, ये कम नहीं है। जो सिपरी ने, मैंने अभी बताया आपको शायद या नहीं बताया, संस्था ने जो सर्वे करी, उस सर्वे के अंतर्गत जो 2020 में टॉप देश निकले एक्सपोर्ट करने वाले 25 कंट्रीज, उसमें पहली बार भारत की एंट्री हुई है। हम टॉप देश में आए हैं। कोई प्रौद्योगिकी तो होगी तभी तो हम यहां तक आए, यानी कि हम बढ़ रहे हैं आगे। अभी जैसे हमारी प्रौद्योगिकी, कुछ जनता, कुछ हमारे प्राइवेट होंगे जो आविष्कार कर रहे होंगे, कुछ हमारे डीआरडीओ के हैं। टरबाइन, गैर टरबाइन इंजन, हाइपरसोनिक मिसाइल, बैलिस्टिक एवं क्रूज मिसाइल, बख्तरबंद वाहन, पनडुब्बियां, 5वीं पीढ़ी के लड़ाकू विमान, सेना की आवश्यकताओं को पूरा करने के लिए उसके वाहन, उसको वहन करके ले जाने वाले वाहक, ऐसे हमारे परिवहन संबंधी इंस्ट्रूमेंट्स, सुरक्षित संचार डिवाइस, सुरक्षित माइक्रो प्रोसेसर और सुरक्षित राउटर्स, साइबर सुरक्षा अवसंरचना, निगरानी प्रणाली, मानव रहित प्लेटफार्मों पर आर्टिफिशियल इंटेलिजेंस और टिक्स, एयर बार्न सेंसर, सामरिक सामग्रियां, ये सब सारी की सारी चीजें हमारी प्रौद्योगिकी के कारण ही आगे आई, जो बहुत तेजी से आज आगे बढ़ रही हैं। इन प्रौद्योगिकियों में क्षमता निर्माण से वर्ष 2025 तक 175 करोड़ रुपए के रक्षा उत्पादन और 35,000 करोड़ रुपए के निर्यात अर्जित करने के राष्ट्र के लक्ष्य को योगदान मिलेगा। यानी कि हमने लक्ष्य भी साथ दिया है। हम कहां तक जाएंगे? हमें एक अंदर से कहते हैं कि धुआं उठ रहा है कि हम आगे बढ़ेंगे। हमारे साइंटिस्ट रात दिन लगे हुए हैं, हम इसमें किस तरह से आगे ले जाएं अपनी प्रौद्योगिकी को। हर जगह पर हम कहीं से कहीं पीछे नहीं हैं। प्रधानमंत्री मोदी जी के मार्गदर्शन में एवं सूचना पर रक्षा मंत्रालय ने डिफेंस सेक्टर में इनोवेशन को बढ़ावा देने के लिए आईडेक्स की संकल्पना प्रस्तुत की है और इसे मूर्त रूप भी दे दिया है। आईडेक्स के बारे में उतना बताने का अवसर नहीं है। अगर मैं बताऊं तो आप आईडेक्स देख लें कितना ज्यादा हम आगे बढ़ गए हैं। हम अपने लोगों के ऊपर खर्च कर रहे हैं। संक्षेप में बताऊं कि आप करो भैया, इनोवेशन करो, आपको जो चाहिए हम लगाने को दे रहे हैं और फिर उनसे ले भी रहे हैं। यंग साइंटिस्ट को आगे ला रहे हैं, यंग साइंटिस्ट को आप करो और हम खरीदार हैं आपकी प्रौद्योगिकी के। इस संक्षेप में अगर मैं आपको बताऊं, आने वाला समय टेक्नोलॉजी का ही होगा। जिसके पास अत्याधुनिक और लेटेस्ट टेक्नोलॉजी होगी वही देश लीडर होगा और सामर्थ्यवान बनेगा। हम नए नए चैलेंजेस जो हैं इनोवेशन में, उसको स्वीकार कर रहे हैं। अगर चैलेंज स्वीकार नहीं किया जाएगा, आगे कैसे बढ़ेंगे? आज विश्व हमारी तरफ देखने लगा है, जबकि हम पहले कुछ समय तक उनकी तरफ देखते थे। तो मैं समझता हूं कि हम कहीं से कहीं कमजोर नहीं हैं। हम लगातार आगे बढ़ रहे हैं। टेक्नोलॉजी हमारी बहुत समृद्ध होते जा रही है। परफेक्ट हो गई अभी मैं नहीं बोल सकता हूं, होते जा रही है। और आज हम किसी से कम नहीं हैं। जिस दिन हमने इंजन बना दिया, आप ये निश्चित मान लीजिए कि उस दिन हम ग्लोबल लीडर बन जाएंगे। ये मैं आपको आज दावे के साथ कह सकता हूं। अभी बहुत तेजी से हम उधर चल रहे हैं और ईश्वर की कृपा रहेगी तो निश्चित हमें सफलता मिलेगी। मैं आपके इतने भव्य सेमिनार की सफलता की कामना करता हूं और जरूर इस सेमिनार के माध्यम से कोई नई चीज निकलेगी और हमको प्रेरणा देगी, ऐसी मेरी अपेक्षा है। भारत माता की जय। यहीं पर मैं अपनी वाणी को विराम करता हूं।
मैं सभी से रिक्वेस्ट करूंगा कि एक बार जोरदार तालियों के साथ में श्री अजय भट्ट जी के लिए, ऑनरेबल रक्षा राज्य मंत्री, मिनिस्ट्री ऑफ डिफेंस, गवर्नमेंट ऑफ इंडिया। अब I would like to request
Mr. Dhaval R, Chairman of Defence Cluster ASHM Gujarat Council, to please kindly step forward for the vote of thanks.
Thank you. On behalf of the ASHM Gujarat chapter, I thank all the participants and speakers. Just to conclude what the various technocrats and foreign OEMs have discussed and what is the roadmap. One sentence I have noticed is the India capable. As Tata Lockheed Martin joint venture, they are producing C-295 tail assemblies, and now they have also started the fighter wings. So this is a one success story. Second, General Atomics also producing some of the products, robotics items here and exporting. For Boeing India, already they are producing and purchasing 8,000 crore worth of the products from India, and recently they have signed in last 18 months they have signed the contracts of 10,000 crore rupees, and again they are exporting. So the list is not exhaustive, but we can see that Indian industry is now transforming into a export-oriented industry in aerospace and defense. If we talk about this futuristic technology and ecosystem and research and development, I believe that lot of things to be done, and I request the foreign OEMs that though the government has laid down the foundation and the vision of Atmanirbhar Bharat and various programs, but the OEMs have a key role into this. I request them to be partner with our academia, be partner with chambers, be partner with industry associations, and please give some technology transfer, set up some center of excellence in the industrial basis so that we can absorb the technology and we can maximize this success story in more platforms and more systems and subsystems. Regarding R&D, I had some discussion with Israel aerospace industry and asked them how much you invest in a research and development for a prototype development or some technology development. So the answer was, they say, we invest about 20 times of the value of this product for prototype. So we are starting afresh. So I believe that we should do more. We should invest 25 times of a product or prototype for the research and development. And this is not only the responsibility of the government. The corporates, foreign OEMs, and the industries should come together for making this happen in India. For Gujarat, sir, we have no defense ecosystem as compared to other states like Karnataka, Tamil Nadu, UP, because we don't have any defense PSU, we don't have any tier 1 manufacturing company here. We have one setup is a SAC ISRO, and all the satellites of the country are designed and manufactured in Ahmedabad. Apart from that, Gujarat has a strong industrial base, and we can make a strong defense industrial base by some hand-holding. Gujarat has 6 lakh SMEs, and out of them 75,000 are engineering SMEs, and our one district, that is Rajkot, has more than 15,000 engineering companies, and they are working for all the Rolls-Royce and automobile giants and supplying and exporting to them. We need some support from the government agencies, from the OEMs, to convert this industrial base into the defense manufacturing hub. And in our pavilion, I request all you to visit Gujarat Pavilion, that is 12A. We are displaying various companies, technologies, and my company, Abhyuday, we are setting up a defense cluster here. We have 600 members at present, and we are doing vendor development. So I request the foreign OEMs to look for some procurement from Gujarat, because Gujarat is a vibrant and industrial state. For aerospace and defense, we are starting some fresh. Now I request all the sponsors and partners of this seminar, Airbus, Boeing, Lockheed Martin, Airworks, Thales, Big Bang Solutions, knowledge partner ENY, and corporate partner Steel Technology SMPP. And in the last, on behalf of the SOCM, I really thank Commander Ajay Panwar for moderating the session very well. This was interactive and it has given very useful information and updates on this sector to the participants. Thank you.
Thank you, sir. On behalf of ASHM, we would like to thank the Ministry of Defense, Department of Defense Production for giving an opportunity for ASHM to associate with prestigious DefExpo 2022. To end with, I would like to conclude by saying a quote, "The best way to predict the future is to create it." And now, before we close, I would like to request everybody for a group picture. I hope this session was quite insightful for everybody. Can we have a big round of applause for all the panelists and the moderator and the speakers here? Thank you. My name is Yash Bothra. I'll be signing off.